Real-time interfaces plus API design. Big idea, one sentence. If users wait in silence, they think the system is broken. So you stream responses, enforce limits at the API edge, and lock the contract before models ever run. 1. Real-time responses. Why streaming matters? LLMs don't think instantly. They think token by token. If your API waits for the full answer, users see nothing, timeouts happen, retries multiply, cost explodes. Streaming fixes perception and reliability. 2. Streaming patterns. AWS expects you to know WebSockets, bidirectional, long-lived, often via Amazon API Gateway. Best when interactive apps, chat UIs, voice agent systems, back-and-forth communication. Characteristics, persistent connection, client can send messages anytime, server streams tokens, events back, server sent events, SSE, one-way streaming, HTTP-based streaming. Best when server client only, browser compatibility matters, simpler infrastructure. Characteristics, client sends one request, server streams chunks, connection closes at end. Exam nuance, you don't need protocol details, just when and why. Nanchar 3, where streaming actually happens. Streaming is not the model's job, it's the API layer's responsibility. Typical flow, you can see the code in our conversation history. If an answer streams directly from the model to the browser. Number 4, token limits and timeouts, API layer control. AWS wants guardrails at the edge, not inside prompts. What you control at the API layer: max tokens per request, max streaming duration, idle timeouts, request size limits. Why? Prevent runaway costs, avoid infinite streams, protect backend resources. Exam signal protect API, cost control, timeouts, enforce at API gateway backend, not the model. 5. AWS Static+1 Real-Time API Edition. Static, API contract, streaming method, token time limits, error handling rules. +1, client request. The API design is fixed. Requests vary. That's Static+1 again. Number 6, OpenAPI-first design. This is very exam-y. What OpenAPI-first means. You design the API specification first, then build the backend. The OpenAPI spec defines endpoints, request response schemas, streaming behavior, error formats, auth. Why AWS likes this? Contracts are explicit, easier to version, easier to audit, easier to generate clients. Exam signal, contract first, governance, API consistency, OpenAPI first. Number 7, why OpenAPI matters more with GenAI. GenAI responses can drift. APIs must not. OpenAPI helps enforce schema validation, predictable response shapes, version changes, client compatibility. If the exam mentions multiple clients, governance, breaking changes, OpenAPI first is the correct answer. Our 8, rapid UI scaffolding with Amplify. Sometimes AWS mentions fast UI delivery. AWS Amplify is useful when you want a quick front end, auth plus API wiring is needed, speed customization. Amplify is never the core answer, it's a supporting tool. Exam rule, if the question is about API design, Amplify is optional, not required. Hammer 9, typical real-time GenAI API design, exam safe. You can see the code in our conversation history. With token limits, timeouts, structured error messages. Mark 10, classic exam traps, very common. Let the model handle timeouts. No API limits needed. Return full response only. UI retries until success. No schema for streaming responses. AWS wants controlled edges. One memory story, lock it in. The live press conference, stream a list, here's answers live. API gateway, microphone plus rules, token limits, time limit per speaker. OpenAPI, press briefing agenda. Amplify, TV studio setup, optional. You don't let speakers talk forever. Exam compression rules, memorize. Real-time UX, streaming. Long sessions, WebSockets. Simple one-way, SSE, cost and safety, API level limits. Governance, OpenAPI first. If an answer ignores the API boundary, it's incomplete. What AWS is really testing? They're asking, can you design GenAI APIs that feel fast, stay cheap, and don't break clients? Not. Can you stream tokens? If your answer shows streaming, limits, contracts, separation of concerns, you're answering at AWS Pro level. Here are 4 real production-grade examples that map exactly to what AWS expects on the exam. Real-time interfaces and API design. Example 1, chat UI with streaming responses WebSockets. Scenario, a GenAI chat app where users expect to see answers as they are generated, not after 10 seconds. Architecture, Frontend opens a WebSocket connection, messages sent via API gateway, WebSocket API. Backend, Lambda service calls the model with streaming enabled. Tokens are streamed back incrementally. You can see the code in our conversation history. Why WebSockets? Persistent connection. Bidirectional, user can interrupt, cancel, or ask follow-up. Ideal for chat and agents. API layer controls, exam gold, max tokens per message, idle timeout on socket, rate limits per connection, max message size, exam takeaway. Interactive, long-lived sessions, WebSockets. Example 2, document Q&A with SSE, simpler streaming. Scenario, a web app where users ask a question about a document and just want to watch the answer stream down. No back and forth needed. Cat architecture. Client sends HTTP request, backend responds with server-sent events, SSE, tokens streamed as events. Connection closes when done. You can see the code in our conversation history. Why SSE, one-way streaming, server-client, works well with browsers, simpler than WebSockets. API limits, max streaming duration, token cap, request timeout. Exam takeaway, one-way, simple streaming, SSE. Example 3, API timeouts and token limits preventing cost blow-up scenario. Users paste huge prompts or maliciously trigger long outputs. Without controls, Lambda runs forever, API retries, massive token costs. Correct AWS design? Controls enforced at the API layer, not in prompts. API gateway, request size limits, rate limiting, backend, max tokens, max stream duration, hard stop after timeout. What happens? Request exceeds limit, rejected early. Stream exceeds time, cleanly terminated. Client receives structured error. Exam takeaway. Cost and safety, enforce limits at API boundary. Example 4, OpenAPI-first GenI API, contract before code. Scenario, a GenI backend is used by web app, mobile app, internal tools. Breaking changes would be disastrous. OpenAPI-first approach. You define /chat stream, ask, request schema, streaming response schema, error responses, auth rules. Only then do you implement backend logic. Why this matters? Clients know exactly what to expect. Schema validation catches drift. APIs are versionable. Governance possible. Exam takeaway. Multiple clients plus governance, OpenAPI first. Example 5, rapid UI demo with Amplify, optional. Scenario, you need a quick demo UI for stakeholders. Solution, use AWS Amplify, wire auth plus API quickly, stream responses to the UI. Amplify is not the core architecture, is just a delivery accelerator. Exam rule, Amplify is supporting, never the main answer. WebSockets versus SSE, real decision table need, chat agent WebSockets, one-way streaming SSE, interrupt cancel WebSockets, simple browser support SSE. If the exam mentions bidirectional, pick WebSockets. Static+1 real-world anchor. Static API contract and API, streaming method, token time limits, error schema. +1, client request API stays fixed, request change. One memory story, lock it in, live podcast studio, WebSockets, live call-in show, SSE, live broadcast, API gateway, producer enforcing rules, token limits, time per speaker, OpenAPI show format, Amplify studio setup. No producer equals chaos. Ultra short exam cheat sheet, real-time UX streaming, two-way, WebSockets, one-way SSE, cost control API level limits, governance, OpenAPI first.